So here is a video to cover the normal distribution for the Math Studies syllabus. The normal curve is also known as the bell curve or the Gaussian distribution after Johann Carl Friedrich Gauss, who was an incredibly famous German mathematician who lived in the late 1700s through to the middle of the 1800s and worked at a very, very famous at the time university called Göttingen. The syllabus says you need to know particular things about the Gaussian distribution. It's used for continuous data. Now remember, data can either be continuous or discrete. Discrete is the one that comes in lumps, like the number of people at a football match only goes up in units. Continuous is something that can take any value, like your height can be 1.8735, so on, meters. And the data must have a symmetrical probability distribution. So for an example, it wouldn't work for effort grades at Malvern College because we have a system that goes from 1 to 6 if you include the S. And most people get a 4, so that leaves the effort grade unbalanced with 2 above the average and 3 below the average. Okay. So you get this kind of shape, this characteristic bell shape. Now it might be a tall thin bell or a short fat bell, but they still have the same properties. What's going on is this is where the averages, the mean, the median, and the mode in this case are all the same, this value here, and the data is spread out on either side. So if you have really tightly packed data, okay, it might look like that. If it's quite varied data, it might look like that. So this links with your calculation of standard deviation. Now the syllabus says that you need to know the proportions of data that are within a certain number of standard deviations of the mean. So it's always a fact that approximately 2/3 of the data will be within one standard deviation of the mean. Now it doesn't matter whether I'm measuring average height and standard deviation for height, or average IQ and standard deviation for IQ, or average weight of a fish. Okay, this is always true. So one that I happen to know off the top of my head is that the average IQ is 100 and the standard deviation is about 14. So that means that across the population, roughly 2/3 of the people will have an IQ between 86 and 114. That's one standard deviation either side of the average. 95% of people will be within 2 standard deviations of the mean. So this is where you're starting to get into things like medical statistics. If you want to classify somebody as under height and perhaps prescribe growth hormone or something, or you want to classify that the heaviest 5% of the people are obese, or you want to classify that the brightest such and such proportion of the people are classified as genius, this is how you would do it. So going back to the IQ calculation, the average was 100 and the standard deviation is 14. So about 95% of people would be below 128 and above 72. Now you might want to think about, suppose your IQ is above 128. What proportion of the population does that mean that you belong to? Just take a moment. Now, the common mistake is people will say it means you're in the top 5%. But we've accounted for 95% between there and there. That means that we've got 5% left over for those people above it and those people below it. So because the spread is symmetrical, that would mean you were in the top 2.5%, not the top 5%. And the final proportion you're supposed to know is that virtually everybody is within 3 standard deviations of the mean. So this is how you can tell whether something is really exceptional. Okay? Anything which is more than 3 standard deviations away from the mean is very unusual. So this is a type of distribution that you'll encounter in your ESS, in your biology, maybe even in business studies and in social sciences like psychology. It turns up everywhere, but you must have those criteria that I said at the beginning. It must be continuous data and it must be symmetrical distribution. So people get a little bit carried away and they tend to think that everything has a normal distribution. That's not quite true. So things which don't have normal distribution are things which are not symmetrical. For example, life expectancy. Let's say that the average life expectancy is 75. That's not too far off. There are occasionally, sadly, babies that die at basically 0 after a couple of days. It's not a symmetrical life expectancy because there's nobody who lives to 150, the same distance the other side, to balance that person out and make the distribution symmetrical. Okay, so the whole point of this is just so you get the idea that not everything follows a normal distribution, although lots of things do. Yeah, that should have rate written at the end of it, metabolic rate. So how do you do maths with the normal distribution? You are expected to be able to solve 2 types of problems. The first is a question that will want you to find the probability, which we represent on the diagram as the area. The second is one where you already know what the probability is. So back to my example of IQ again, but if we know the mean and the standard deviation, so the mean is here at 100, standard deviation, a measure of spread, is 14 either side, I want to find the probability of choosing somebody at random and finding that their IQ is between 90 and 101. So all you do is you go to your calculator, you go to distributions, and you find the normal CDF, probability distribution. You follow the instructions on the screen, so you tell it that the lower bound is 90, the upper bound is 101, the mean for your distribution was 100, standard deviation was 14, and it should tell you that the probability of being between those 2 within this distribution is 0.291. So that's if you want to find the area. If you're given the area, so you're given the probability. So in this case, I've been given that the mean is 80, the standard deviation is 12, so I've been told about the distribution, and I want to find the value so that 90% of people are less than that value. So maybe this is a medical statistic and you're defining as obese or overweight everybody who's in the top 10% of the population by weight, for example, and you want to find out where that threshold is. So you go to the same place on your graphic calculator, distributions, but this time you go to the inverse normal distribution. Okay, this is if it's told you the area. And we give it the information that it asks for. So the area is 0.9. We've got a mean of 80, a standard deviation of 12, and it should tell us to 3 significant figures, therefore, that our value, by the time we've accounted for 90% of the area, is 95.4 kilograms. So that would be that point there. That's it. That's all there is to the normal distribution for math studies.